Okay, miscellaneous exercise 8, question 10 is actually a question which has got a dagger by it, which means it's really beyond the M1 curriculum, but I'll do it anyway. What you've got to understand here is the reason it's beyond the M1 curriculum is that you have two boats or punts which are drifting slowly past each other. Now, the reason this is off the syllabus is that the two boats obviously are not going in the same straight line, otherwise they would collide into each other. They are in fact just passing alongside each other. Both of them contain passengers and have a total mass of 930 kilograms. One is going this way at speed p, and B is going this way with speed q, and we don't know which is greater out of p and q. Okay, so just simplifying this, before any, and we haven't really got a collision here, but before the incident, if you like, I'm going to model A as a particle with a mass of 930 kilograms moving in this direction with speed p, and B, so I'm going to model them as going in a straight line, has got speed q in the opposite direction and also has a mass of 930 kilograms. What you're then told is that one of the passengers gets out of A and steps over into B, and that passenger weighs 70 kilograms. So after this incident, the mass of A becomes 860 kilograms. You are told, though, that A continues in the same direction at the same speed. So that's what happens with A. B, on the other hand, we don't really know what happens to B. The mass goes up to now 1,000 kilograms, and we are told, and we don't really know what happens to B, but let's assume we are told that the new velocity of B is going to be r. And because I don't know what it is, whether it's going to go to the right or to the left, I'm just going to assume that it goes to the right, and if I'm wrong, then I should be able to figure that out. Okay, so let's have a look at the conservation of momentum. Before the collision then, for A, we have got the mass times velocity, well that's 930 p, and that is added to, now here, the mass times the velocity, 930 is the mass, but the velocity, because it's to the left, is going to be minus q. And that's going to equal, so we look at A now, the mass times velocity for A is going to be 880 times p, and the mass times the velocity for B is going to be 1,000 r. Okay, let's carry on. So this is 930p minus 930q is equal to 860p plus 1,000 r. And our job is to find out what r is. So all I'm going to do is I'm going to move this 860p to the left. In other words, I'm going to get 70p minus 930q is equal to 1,000 r. If I divide through by 10, I've got 7p minus 93q is equal to 100r. In other words, r is equal to 7p minus 93q divided by 100, which is the same as 1/100th, and that's 7p minus 93q. Now, what this assumes, if we look at our answer here, that is assuming that r is actually to the right. Now, what we're told is that q's speed, what are we told? The speed and direction of punt A remains unchanged. The speed of punt B, now before, B was moving to the left, and we're told that its speed has now reduced. So I think we're going to have to assume that it's going in the same direction. So if r is to the right, then r is 1/100th of 7p minus 73q. But in fact, if we take r to be to the left, then actually the speed of r is going to be 1/100th. And I'm going to turn that round and make it 93q minus 7p. So if we are assuming that punt B is continuing in that direction, then its speed will be the given answer, which is 1/100th of 93q minus 7p. I've just changed the signs to reflect the fact that r is actually in that direction. So I've now got a new before and after situation. So I'm now going to take before to be with after the passenger has jumped from one boat to another. So before anything else changes, we've now got punt A, which has a mass of 860 kilograms, continuing with speed p because its speed hasn't changed. and we've got punt B, which has got now the greater mass because the passenger has moved, 130 kilograms moving in this direction with speed r. Okay, what happens now is that before the boats actually move apart, the passenger gets back into his original boat. So he gets back into A, which now goes back up to being 930 kilograms. And we don't know what happens to A, but we just know that it's going to continue at speed V. We're told, though, that B, once the passenger has got out, so he goes back, this one goes back to being 930 kilograms, continues with speed R. Okay, so let's have a look at the conservation of momentum now. We've now got mass times velocity for boat A before this incident, if you like, and the incident that's happening here is that the person returns to boat A. Okay, so we've got 860 times P plus 1000 times minus R, because R is actually to the left, is going to be equal to 930 V plus 930 again times minus R. So we've got 860p minus 1000 R is equal to 930 V minus 930 R. Okay, so let's make V the subject there. So we've got 860p minus 1000 R, but that then plus the 930 R is equal to 930 V. So we've got 860p, that just comes out as minus 70 R is equal to 930 V. Dividing through by 10, we've got that. So V is going to equal 1/93 of 86p minus 7R, which is what's... But we know that R is equal to 1/100th of 93q minus 7p, so I'm just going to put the two together now. So my V is 1/93, and then we've got 86p minus 7r. Well, let's write it as minus 7/100th of 93q minus 7p. Okay, so let's carry on. So it's 1/93 into 86p minus, so let's write it as 7 times 93 over 100 q plus 7 times 7 over 100 p. Okay, so that's just 86p over 93 minus, now here the 93s are going to cancel, so it's minus, oops, hang on, minus 7/100th q plus, let's say 49 over 9300 p. Okay, so put the p's together. I'm going to put both the p's over 9300 just to make life a little bit easier. So I've got 8600p plus 49p all over 9300 minus my 700th q. So that's 8,649p over 9300 minus 700th q. So if I take out the hundredth now, so that's a hundredth. So I've got 8649p over 93 there minus 7q there. And actually, if I do 8649 over 93, that comes out as, yeah. So that's just 100th, and then that comes out as 93p minus 7q. Okay, the last bit of the question gets you to look at sort of the overall situation. So if we look at what has happened, we know that momentum is going to be conserved. So if we look at the very start, we've got A, which has got a particular mass, m, in other words, the 930 kilograms, moving to the right. And this is, asks us to now look at what happens if they have equal speeds beforehand. Now, if they have equal speeds beforehand, let's call that equal speed p. So you've got A moving with speed p to the right, and we've got B also moving with speed p to the left. If we look at what happens after, if you like, we've got the middle stage where the person goes from A to B, and then we've got the second stage where they go back again. So if we miss out that middle stage, what is going to be happening afterwards is that B is going to be continuing. If you like, they've swapped places because they've sort of driven past each other. Okay, so A is now going to be continuing to the right because they've gone past each other, and B is going to be continuing to the left. Now, the only way that that can be true, because if you look at the end of the whole incident, the masses of both of those are exactly the same. The only way, if these two speeds are the same, the only way that momentum can be conserved is if this one continues to go with speed p to the right, and this one continues to go with speed p to in the opposite direction. Now let's just verify that. Okay, so the verification that they are looking for. Okay, so we know that after the second move, we know that A is travelling with speed v, and we know that B is travelling with speed r. And we worked out expressions earlier for those. We know that V is equal to 1/100 of 93p minus 7q, and we know that R is equal to 1/100 of 93q minus 7p. Now, essentially, if we look at those two expressions, if P and Q are no longer different, but they're in fact exactly the same, then V, let B will be 1/100 of 93p minus 7p, in other words, 1/100 of 86p. And if we look at this one, this is also going to be, if I change the Q into a P, it's again going to be 93p minus 7p. So R is also going to be 86p over 100. So our two expressions for V and R back up the fact that if the velocity of both of them to start with is exactly the same, if the speed is the same, then what will happen is that the speed of both of them, V and R, will actually just be exactly the same.